Have you ever looked around and marveled at the magic of the everyday world? Each day, we are surrounded by a symphony of sights and sounds, a blend of the mundane and the mystical. It's easy to overlook the everyday miracles that occur right before our eyes, yet these seemingly ordinary occurrences hold extraordinary secrets. From the morning dew that sparkles on a spider's web, to the way a rainbow paints a canvas across the sky after a storm, there's a wealth of wonder hiding in plain sight. The world around us is a treasure trove of scientific phenomena waiting to be explored and understood. Every moment is a testament to the laws of nature and physics at work. Unlocking these mysteries allows us to appreciate the beauty and intricacy of the world in a whole new light. Take, for example, the curious phenomenon of objects appearing to disappear in water. It's like witnessing a magician's trick, but the explanation lies not in sleight of hand, but in the principles of optics. This statement may seem perplexing at first, but let's dive into the scientific concept of refraction to unravel the mystery. Light, as we know, travels in straight lines. But what happens when it encounters a different medium? It changes course, a phenomenon known as refraction. Picture light as a car. When it's driving on a flat road, it travels straight, but when it hits a speed bump, it changes direction. This is essentially what light does when it moves from air into water. But how does this refraction make objects appear distorted or even invisible in water? Well, it's all about the angle at which we're observing. When light refracts or bends, it alters our perception of where the object is. If the angle of refraction is just right, it can make the object seem to disappear entirely. Imagine you're looking at a straw in a glass of water. From your perspective, the straw appears bent at the water's surface. This is refraction at work. The light from the submerged part of the straw is bending as it emerges from the water, causing the straw to look distorted. Now, if you were to gaze at the straw from a different angle, say directly from above, the straw might appear to vanish entirely. This is because the light rays coming from the straw are spreading out so much that they're not reaching your eyes. The straw hasn't truly vanished, of course. It's merely hidden by the trickery of light. So next time you're taken aback by an object seeming to vanish in water, remember, it's not magic, it's refraction. Similarly, the enchanting colors of a rainbow are no mystical creation, but a beautiful display of the science of light. Understanding these everyday phenomena enhances our appreciation of the world around us and the intricate science that makes it all possible. Rainbows form when sunlight is refracted and reflected inside water droplets, separating white light into its constituent colors. Yes, the captivating bands of color arching across the sky aren't the handiwork of leprechauns, but the result of a fascinating process that begins with a beam of sunlight and a sky full of raindrops. Sunlight might appear colorless, but it's actually a mix of different colors, each with its own unique wavelength. When a beam of sunlight enters a raindrop, it slows down and bends or refracts, separating into its various colors. This is much like a prism that disperses white light into its constituent spectrum. Now, within the droplet, the light doesn't just pass straight through. It reflects off the inside surface of the droplet, bending again as it exits. This double refraction, coupled with the internal reflection, results in the light spreading out and creating the radiant spectrum of colors we see in a rainbow. From red to violet, each color emerges at a specific angle. Red light at about 42 degrees from the original light path, and violet at about 40 degrees. This slight difference in angles results in the different colors fanning out to form a circular arc, with red on the outside and violet on the inside. So the next time you see a rainbow, take a moment to appreciate the intricate dance of light and water that makes this ethereal spectacle possible. But wait, there's more to the story of light and color. And what about the endless expanse of blue above us? The sky's azure hue is a result of a phenomenon called Rayleigh scattering. Yes, the same sunlight that gives us rainbows also paints the sky blue, but that's a tale for another day. When sunlight enters Earth's atmosphere, its shorter blue wavelengths are scattered more than longer wavelengths, like red, causing the sky to appear blue to our eyes. Now you might be wondering, what does it mean for light to be scattered? And why does it make the sky look blue? Well, let's break it down. First, let's talk about light. Light, as we know it, is made up of different colors, each with its own wavelength. Blue light has a shorter wavelength, and red light has a longer one. When light from the sun enters the Earth's atmosphere, it encounters molecules of air and tiny particles. As it does so, this light bounces off or gets scattered in different directions. This phenomenon is what we call scattering. But here's the thing, not all colors of light are scattered equally. The shorter the wavelength of the light, the more it gets scattered. And since blue light has a shorter wavelength than red, it gets scattered more. This scattering of light is known as Rayleigh scattering, named after the British scientist Lord Rayleigh who first studied it in detail. So when we look up at the sky on a clear day, we see it as blue because of all this scattered blue light reaching our eyes from all directions. But what about sunsets, you might ask? Why do they often appear red or orange? Well, during sunrise or sunset, the sun is lower in the sky, and its light has to pass through more atmosphere. This means even more scattering occurs, but this time, the shorter blue and green wavelengths get scattered out of our line of sight, leaving the longer wavelengths like red, orange, and yellow to reach our eyes, giving the sky its beautiful, warm hues. These are just a few examples of the science behind the magic we encounter every day. By understanding these principles, we can appreciate the beauty of our world in a whole new light. So the next time you look up at the sky, remember the fascinating science that makes it all possible. By understanding the principles at work, we can unlock the secrets of the world around us and appreciate the beauty and wonder of nature in a whole new light. The trick of the invisible? That's refraction at play, bending light and playing with our perception. The vibrant hues of a rainbow? Not a mystical creation, but an exquisite dance of sunlight refracted and reflected inside droplets of water. And the endless blue of the sky? That's all thanks to Rayleigh scattering sunlight and painting the sky with its shorter blue wavelengths. All around us, the science behind the magic unfolds, transforming the ordinary into extraordinary. These phenomena are not tricks or illusions, but rather nature's own science experiments. And by comprehending these principles, we don't lose the magic. Instead, we gain a deeper appreciation for the intricate, awe-inspiring world we inhabit. So next time you witness something seemingly magical, remember, there's science behind the enchantment.